All right, this is 7.1. We're looking at properties of similar triangles. Now we have watched a couple of videos. Who can tell me the difference between a similar triangle and a congruent triangle? Lucas. A little bit louder? Yeah, it is the same, congruent, right? Looks the same, it is the same. It has the same size, it has the same angles. RC, what's a similar triangle? We just covered this at the beginning videos. So he told us congruent is the same triangle. What's the difference between congruent and similar? Congruent is exactly the same. What is similar? Two similar triangles. Sorry? They are. What makes them similar though? Same shape, yes, but more specifically than that, Rudy? Yeah, the sides. If all the sides have the same ratio, they have the same ratio, or all the angles are the same, that's what makes them similar. You guys understand that? Okay. We're going to see some examples of that. So similar figures, polygons that have the same shape but different size, and congruent polygons that have the same shape and size. So are the rectangles similar? So one way we can check, they look similar, but we need to check, actually, they're not congruent, right? They're not the same size. So we know they're not congruent. We want to know is the shape ABCD the same as WXYZ, if they're similar, okay? So one way we can check this is we can check the ratio of the sides, okay? So is the ratio of AB over WX, so I'm checking this side, is that going to be equal to the ratio of AD, this length, over XY, or WZ, right? So we need to check, are these ratios the same? So basically, is this size growing at the same scale as this side is growing? Okay, that's what we need to find out. So we sub in for AB 18, and we sub in for WX 25, and then we sub in 36, and then we sub in 45. So we need to see if these two are the same. They could be off by like a very little bit, in which case they wouldn't be similar triangles. So we get 0.72, and we get 0.8. Uh-oh. So even though they look similar, are they similar? They are not similar because the ratio of the sides are not the same. In other words, the scale factor is not consistent. So it's not being scaled up precisely. There's no one number that I can multiply both of these to get these two numbers. Okay? The ratio is not the same. Yeah. You're trying to give me an example of when they are similar? We're going to see a whole bunch. Okay? Just hang in there. The answer was probably going to be yes, but it's hard to visualize what you were saying. We're gonna see a bunch of examples that are similar. But basically, what you're checking to see if it's similar is the ratio of the sides, and it's important that you pick the same side, right? If you don't pick the right side, they're not going to be the same. You have to pick the same side. Okay, so are triangles similar or congruent? So we're looking at these two triangles now. So it's important the order in which you write these vertices, these letters, okay? So I would write out, if I write triangle ABC, so I'm going to write this, is triangle ABC similar to triangle, now I can't write ZYX, because it won't be if I write my vertices wrong. If I'm saying ABC, I have to say X, Y, Z. Does that make sense? You have to line up your vertices and go the same direction. Otherwise, your proportions, when you go to compare them, you won't be comparing the same sides. So that's important, okay? So we're trying to find out, is ABC the same as X, Y, Z? So the way we do that is we need to compare the ratio of the sides. So is side A B, this side, over XY, is that ratio equal to the ratio, let's do the hypotenuse, so AC over XZ. I'm checking. Is this side over this side, so the ratio, the scale factor that this needs to be multiplied to get to this, which is clearly 2, right? We can see 3 to 6. Is that going to be the same as the scale factor that I need to multiply this side, 5, to get to 10? Some of you might already see it and say yes it is, but we're going to put them in. So 3 over 6 is equal to AC 5 over 10. So this is 1/2 is equal to 1/2. So this is correct. These are similar because the ratio of the sides are the same. Does that make sense? Anybody lost? Yep.
How do you check if it's congruent?
Congruent?
Yeah.
If it's the exact same number. So the sides have to be the same. They have to be the same values. And the angles have to be the same. Okay? Congruent's pretty easy because not only your ratios have to be the same, but your sides have to be the same. So you can kind of just see if, like, if you know all the information about the triangle, you should be able to tell if it's the same triangle, right? Okay, so if ABC is similar to XYZ, we write triangle ABC is similar to triangle XYZ. That's what we write. The order we write the vertices is important. I've just gone over this. So you have to go the same way. Otherwise, you're not comparing the same sides. So that's why that's important. In similar triangles, corresponding sides are, the ratios are equal. So corresponding sides are what? They are proportional. Okay, so that means AB and XY, AC and XZ, and BC and ZY are proportional. Okay, and that's what I checked over here. That's what I checked. Made sure that they were proportional. So corresponding angles, the angles that correspond to the different sides, like C to Z, right? The angles that go with the vertices, X and A. The angles are what? What do you think? So the sides are proportional in similar triangles. What do you think the angles are? Yeah, exactly. They are the same. They're equal. They have to be for similar triangles. Your angles all have to be equal. Corresponding angles are equal. All right, so given that our ABC is similar to XYZ, we can say AB over XY is equal to BC over YZ is equal to AC over XZ. Anyone confused, or are you guys still with me? My sides are proportional, right? Because my triangles are similar. So now my angles, I can say angle A is equal to, Douglas? Angle X. Yeah, if I can get this on here. Okay, angle B is equal to, angle B is equal to, I'm going to go up and down here. Alan, angle B is equal to what? Angle Y, good. Milkias, angle C is equal to, sorry? Yeah, angle Z, I think you said, right? Or Z. Okay. So note, if you are not told that true triangles are similar, you cannot assume they are, even if they look like they could be. If I asked you this question on the very first one, these aren't triangles, but they're quadrilaterals. I said if they were similar, you might say yes, because all the angles are the same. But the sizes are not proportional. They don't have to be the same, the side lengths, but they have to be proportional. Okay? You must prove that two triangles are similar before you can use any of the two properties. So that's important, right? You have to prove them. You need to check. This is the proof. I'm checking the ratio, the proportions of the sides. If they are not the same, they're not similar. If they are the same, they are similar, and then I can make inferences about the rest of the triangles, the rest of the angles, everything else. Okay? All right. So how do you prove two triangles are similar? There's three ways that we can do this. Okay? Three ways. I showed you one way. What's one way that I've already showed you? Yep. Yes, the ratio of the sides. Okay, so that is one way. You can check if the sides are proportional. Okay? So that's what the first one is, this side similarity. Okay, we call it SSS. And what do we check? We check three sides of one triangle are proportional to all three sides of the other triangle. Okay? That's the first one. Yep. Bathroom. Side angle side, SAS. So this is when we have an angle between two sides, and we find out that the side lengths between that angle are proportional. So we don't have to check all three proportions here if we have one angle. The angle's already the same. So if sides around the same angle are proportional. And I'm going to show you examples of this, okay? But basically, if we know one of the angles is the same, we don't have to check all three proportions. We only have to check the two around that angle. I'm going to show you examples of this. And the last one is if we have two angles are the same. Obviously, if two angles are the same in a triangle, the third angle is going to be the same, right? Because all triangles have a sum of 180. So if two triangles have two angles are the same. So if two triangles have two angles the same. Okay, these are our three methods of determining whether triangles are similar or not. All right, so the one we're going to use is dependent on the information we're given. That's how we're going to decide what to use. All right, I'm going to say that one more time. You're going to decide which one you're using based on the problem, what they're giving you. Okay, so in this case, we can see two triangles here. What are we given? Here. All the sides. So which one do you think we're going to use? Yeah, side by side. We're going to use the first one because we don't know any angles, but we know all the sides. So, therefore, we're going to check. Is triangle ABC similar to triangle D? Now this is important. Go the same way, the same order. DEF. That's what we're checking. Now, I could ask you right away, are they congruent? Are they? They are not congruent. Nope. How do you know they're not congruent? Jafet, why are they not congruent? Yeah, different lengths. They're not the same size, right? We can see right by here, 14 is not 7. Okay? Are they similar? They are. We know right away because if you're good with math, you can see that 14 is double 7, 6 is double 12, and 15 is double 7.5. So you can see the proportions are the same. But we have to check, right? So let's check. We'll say, let's check the proportions. So we're going to use method 1, side, side, side. And we're checking the proportions. We want to see is AC over this proportion DF equal to AB over DE, which is equal to BC over EF. That's what I'm checking. All right, so then I just sub these in. 14 over 7 is equal to 12 over 6 is equal to 15 over 7.5. So this is 2 is equal to 2 is equal to 2. Yes, they are. All right, B. Now we have no sides. So which one do you think we're going to use? Yeah, AA, angle similarity. So if two triangles have two angles the same, they are similar. Look at these angles. We have two that are the same. So we have one that's the same, 81 and 81. We don't know about this angle. We got to find it out. These two are not, so let's do it. What is this angle C? Yeah, Lucas? Yes, 180 minus 81 minus 60 is what? 39? And I'm going to get 39 here as well. So we then know that there are two angles that are similar. Okay, we can say 39 and 81. Oh wait, that can't be right. Can it? Oh, this is not. Hold on. Hold on a second. Oh, did I maybe miss here? 59. So this is 59, my bad. And this is 39, right?
So which one were you asking for first?
Yeah, I think I was asking for F, but I think he gave me C. Okay, so here from we're checking here is triangle ABC. This ABC is equal to triangle DEF. Now it's important we go the same direction. ABC DEF. Okay? So from triangle ABC, we know angle C is equal to 180 minus 60 minus 81. So we know angle C is 39. And from triangle DEF, we know angle F is equal to 180 minus 40 minus 81. So angle F is equal to 59. Those are our two other angles. So what we find out then is we have 81 in common, but we don't have another angle in common. Therefore, the triangles are not similar. Triangle ABC is not similar to triangle DEF. And that was proven because their angles are not the same. Yep.
For us to show our work, we have to like break it down all the time.
Yeah. All right, C. These two are not similar. They look pretty similar, but they were not. They're proven not to be similar. All right. Last one. We can see here we have an angle trapped between two sides. So we are going to use side similarity. We're using that because we have this scenario of side, angle, side. So what we need to determine, if we have the same angle between two sides, if those two sides are proportional, the triangles are similar. Okay, so is triangle P Q R similar to triangle Y. Now I have to pick the right directions here. X, Z, right? Because I'm ending on angle 75. So the way we check this is we're going to use side, angle, side. This is 3. And we're going to check the proportion of the two sides that are sandwiching the angle. So we're going to say 8, or let's write it out here. So side PR over ZY is equal, PR over ZY is equal to RQ over ZX. So 8 over 4 is equal to 2. Oh, sorry. So I'm checking this side, PR, that's the longer side of the 75, over ZY, that's the longer side, so over 2, is equal to RQ, the shorter side on the 75, this side 4, over ZX, 1. So we get 4 is equal to 4. Therefore, triangle PQR is similar to triangle YXZ. Any questions there? Alright, we've got 2 more pages of examples. Let's do it. So it says, state if the triangles in each pair are similar. If so, state how you know they are similar. Actually, what I'll do, I'll do the first page. You have the answers here, and the second page we'll decide what we're going to use, and I'll let you guys do that for homework to figure out what is equal. Actually, we'll do that for all of them. Okay. So state if the triangles in each pair are similar. If so, state how you know they are similar and complete the similarity statement. So triangle UTS. So this is the triangle we're looking at, UTS. We want to see if that's similar to this triangle. Now it's important that we pick the same orientation. So we want to do triangle U, we want to go D, E. Okay? So we're checking if these two triangles are similar. Now, I know they're not, I can see, because these two sides are equal and these two sides are not. So I know they're not going to be similar, but we need to check. Okay, so we're going to decide what method to use. We're either going to use method 1, side, side, side. We're going to use method 2, side, angle, side. Or we're going to use method 3, side, angle, angle. Right? So which method are we going to use? Yeah. Yes, SAS. Why? Because we know with opposing angles that these two angles are the same, and we have information about the sides surrounding them. So we need to know if the ratio of the sides surrounding them are the same. We don't need to know what the angle is because we know they're the same, but we need to check the ratio of the sides. So we need to know if 39 over 16 is equal to 40 over 16. Right? This is the ratio. This side over this side is equal to this side over this side. And we can see that they're not. So therefore, these two triangles are not similar. They're close, very close, but not similar. Okay? Any questions there? All right, we're going to go a little bit quicker here because we got 5 minutes left. Number 2, we are checking if triangle CBA is similar to, now I'm going to go the same route. So I want to go F, right? FG, H. That's important, that you're going to the same vertices. Okay? Now here we have information about all the sides. So which one are we going to use? Liam? SSS, good. SSS, that's what we want to use because we have information. So if we don't want to do all the letters, let's just do the sides. So we'll do with the hypotenuse first. 84 over 14, is that equal to 72 over 12 is equal to We get 6. We get 6. And we get 6. So yes, they are similar. Okay? Alright, quickly, let's just talk about which one to use now. This one, number 3. We have information about 2 sides, and both those sides are sandwiching the same angle. So this one we're going to use SAS. Okay, you'll figure that one out yourself. This one we have this angle is the same as this angle, and this angle is the same as this angle. That's all we got. What are we going to use? AA, that's correct. Yes, we're going to check if 2 of the angles are the same. If they are, we know the third angle is the same, and we're good to go. They're similar. This one, we have opposing angles here. We have, so this was an interesting one. Look, we have all angles, no sides, right? We have information about 1, 2, 3, 4, 5 angles. So what are we going to use here? Angle, angle. Okay, and here we can see already that this triangle here shares one angle that's the same as here, and this angle is different than those two. We need to check if this last angle is the same as any of these, right? We can see from Z pattern here, if this is parallel, then this angle is the same as this angle, so they would be similar. Right? Angle, angle, angles, probably the easiest. Let's see, 5 if I was right. 5 similar. Oh, 5 not similar. This angle's the same. This angle is different. Oh, yeah, you can't assume that this is parallel to this. You cannot assume that. Right? Because we don't have those parallel lines here. So we can't assume that. So you would have to check, find out what angle C is. All right, number 6. We are going to use side, angle, side again. Why? Because we know this angle is shared by both the little triangle and the big triangle. And we have information about the 2 surrounding sides. This side is 107, this side is 88, this side is 16, and this side is 25. This is a triangle within a triangle. You need to use SAS. Okay? I will help you just with what to use. This one we have information about all the sides. We're going to use side, side, side. This one we have information again about similar angles, angle, angle. This one we have all angles, angle, angle. This one we have side, angle, side. This one is also side, angle, side, and that's because this angle is the same. And finally, number 12, also side, angle, side, because this angle is the same and we know information about the sides. This angle is the same for both the inner triangle and the outer triangle. Okay, that's it.